Bueno, muy buenas tardes, noches a todos. Un gusto saludarles y darle la bienvenida a esta sesión de Build with AI 2026. Soy Adelaide Zelaya, organizadora de GDG Tegucigalpa. Creo que este tema que vamos a estar visualizando el día de hoy le va a ayudar bastante como a los desarrolladores. Sabemos que en el desarrollo de software actual la velocidad es clave, pero también sabemos que la calidad no puede quedarse atrás. Creo que les ha sucedido que han pasado horas en revisiones de código para ver cómo reducir el tiempo de ejecución y demás. Por lo tanto, hoy vamos a aprender en esta sesión cómo potenciar ese proceso. Por lo tanto, tenemos como menciona el título, vamos a estar viendo el AI Code Review Assistant with Google ADK. Okay. To lead this workshop, we have an incredible honor to have a true expert in the field with us today. He's a senior AI data scientist at AVM and a recognized Google developer expert in cloud AI. With over 8 years of experience in software engineering, he bridges the gap between traditional development and the cutting edge of artificial intelligence. So thanks for being here, Pedro. I will give the stage to you right now. And if you're here.
Hey, thank you so much for this kind introduction. and also for having me. So, hi for everyone who is watching this live, or for any other folks that may watch this after we finish this on live. So, it's a pleasure to be here and also an honor for me. And I want to thank the whole GDE team for inviting me to be here today. So, yeah, I will share the slides right now.
Okay, thanks.
Yeah. Let me know if you can see my screen right now and if it is clear for everyone. Nice. So today we're gonna build an AI code review assistant with Google ADK. And before we start, a little bit about me. My name is Pedro Lara. I'm from Brazil. I work as a senior data scientist at IBM with focus on applied AI. I am recognized as a GDE in cloud AI, so applying Gen AI to a lot of things. I am also an international speaker. I have the certification of AI machine learning by the University of Texas at Austin. I love to travel. I am Christian. I am a husband, and right now, my most special title, I am a dad of Clara. Clara is still on the belly of Bianca, which is my wife, and she's expected to born in September 14. So as soon as she came to this road, I will, of course, send a picture for all of you. This is my Instagram and my LinkedIn. So if you want to post something, please tag me so I can track the engagement through this session. A little bit about what I have been doing at IBM. I have been building AI solutions in enterprise scale with AI for tech education. So we are being working with performance for engineering teams. So we can pretty much track all the things that the developers are doing right now and analyzing this with AI. Another thing that I have worked at is on this benchmark. So it is a world famous benchmark. If you see the model card for the Gemini 3.1 Pro, if you're gonna notice at the end of the page that they are gonna mention this benchmark. So I have worked on the version 3 with doing harness with a lot of models, not only Google ones. So it is a curious fact. And here we came to our agenda. And then after the intro, I want to give a very quick overview about the problem that we are going to be solving today. And I don't know if everyone is a developer at this audience today, but if you are, you may have faced this situation at least one time in your life when you wake up trying to solve a bug for hours and hours and hours without getting the solution ready at your mind. So you keep looking, keep looking, keep looking, and you cannot find the solution for that. So what do we decide to do after spending a lot of time trying to solve a problem? Maybe send to the AI, right? So maybe we're gonna open Gemini.com and then we're gonna paste the piece of code that is with a bug that we cannot see, and then we're gonna wait for an answer. But I want to make a little provocation today. Like, is this a good solution? Like, is this a good approach? If we get the piece of code that is not working fine, and then we paste that into the model, which can be Gemini or it can be any other model, is this a great solution? Maybe you can answer me that, yeah, it is like a fair solution. And it is, right? Because it's going to answer you like, I see that you have this error here, and then you need to solve it like that. It is a great solution. Maybe if you get the suggestion and apply the suggestion, you're going to get the code working again. But can this kind of approach, this one-shot approach to the LLM, really parse the AST and understand the structure of that code? Can this one-shot answer run tests on your code and see if your code is really working? Like testing, running the code on the background and seeing if this worked or not? Can it check the style compliance on the code? Or can it remember from your previous reviews? For example, if you're committing the same mistake for the third time, can it get that kind of memory? Maybe not. So what we're gonna do today is that we're gonna build a solution that is much more complex than that, that is gonna help us in a lot of different ways. So instead of just asking the LLM what we should change on our code in order to solve that bug, we're gonna build a real AI pipeline where we can analyze the code, where we can test the code, where we can synthesize our feedback, and if the agent, the agentic pipeline finds that there is a bug on our code, we're going to be able, with another pipeline, to really create a fix. So our pipeline that we're going to develop today is going to auto fix the code that is broken. And it's going to try it 3 times before escalating to the final report. So this is what we're going to be building today. We are going to get the code, and this is an example, the DFS search. So if you look here, it's the same example. So we get the code sample. We call our orchestrator that is going to call our first pipeline, which are going to name it review pipeline. It's going to first analyze, then make a style check, then test our code, and then synthesize our feedback. After that, if it is requested to create a fix, it is going to run the fix pipeline. And into this fix pipeline, we're going to run our code, we're going to create a fix, we're going to test the fix, and you're going to validate the fix. If the fix is not good enough, we're going to run this pipeline 3 times in the max limit, and we can change it later, but the recommended is 3. And at the end, if it is able or not, it's going to create a report for us. So that's what we are going to do. And in the process of creating it, we are going to pass through many different concepts regarding ADK. So ADK is the agentic framework for orchestrating agents in code environment that Google has sent for us. So, unfortunately for this session, Google have made an emergency maintenance into the credit system. So we're not gonna be able to give you guys credit to use on Google Cloud Platform. So this is really a bad thing, but they are making this work. And as soon as they do, maybe the GDG Tegucigalpa team is gonna answer you guys with the link, so you guys can request your credits in the future, right? So our demo today is gonna be on this code lab. I will share the link with all of you. And let me just share here. I think the GDG team maybe can send for me on the comments for everyone. Yep. And this link is gonna open this page, right? So this is our code lab. Code labs is a way that Google has made for us to make easy to follow some coding steps. And this is the one that we will be doing today. And also with the code lab, I need everyone to open this console.cloud.google.com, right? So an important thing here, you should have your account with a created project. So if you came up here at this screen and you don't have a project right up here, you should click and then create a new project over here, right? So as soon as you do, you're able to proceed with our code lab. Today, we're gonna use a tool called Cloud Shield. This is gonna allow us to run code into a Google machine instead of our own machine. So we can use all the Google computational power to run our code lab and our code. So we can pretty much create a lot of things using Google technologies and Google virtual machines over here, right? Another cool thing that I want to show with everyone is that you have a virtual version of the Google, of the Visual Studio Code. So if you click here, you're gonna not only see the terminal, but you're gonna see a virtual instance of the Visual Studio Code. So this is the 2 tools that we are gonna work today, both the terminal on the Cloud Shield and on this instance of the Visual Studio Code, right? So we're gonna start. Let me just pass this introductory step that I have already done with all of you through the slides. And this is gonna step by step tell us what we should do on the Cloud Shield. So first thing we should do click on the Cloud Shield, open the terminal right here, and then we're gonna proceed doing our things. So the first thing we're gonna do is set our project inside of the terminal. So this is gonna tell the Cloud Shield instance that we wanna use that project as the standard, as the default for our lab execution of today. So if you copy this and place an echo before, you're gonna see the project that is selected, right? So this one should be the same as this one. So if you look, they are both the same. So what we're gonna do today is copy this command right here and paste this right here. So this is gonna set the project, the core project, as the one that we have been choosing on the top. Nice. After that, we're gonna run this other command up here that is gonna authenticate our Cloud Shield, and you can press Y on our terminal. So this is a link you can click and proceed with your authorization. This is gonna link, and this is important because you should select the same Google account that you have selected when you log in on the Cloud Console. So it must be the same, otherwise it will not work. And then you're gonna notice that you have two boxes right here. You should copy the second one and then paste the second one here. So this shows for us that we have been authenticated. After that, we should enable the services that we want inside of GCP. So we're going to enable the AI platform and then compute platform inside of Google. This can take some amount of time, but generally is fast, right? You should expect this operation, then you're going to send you the resh, and then finish it successfully. This is the signal that everything has been okay. If you face some type of error here, just follow what the error is saying and then complete. For example, it should require you to add a credit card, or sometimes it can require you to make some two-factor authentication or whatever. So if something is not good with your account, it's gonna show up here. And then just follow the message and keep going, right? So the first thing we're gonna do is installing the libraries that we want. I don't know if everyone has worked with Python before, but Python has a thing called packages or libraries. And this is like usable pieces of code that other person has published for us to use. And Google has published this one, Google ADK. And this is the one that we're gonna install today. And if you have worked with Python before, you can notice that I didn't create a virtual environment yet. So for this stage, I want to install this library globally, and then after it, I will create a virtual environment on our final project. But for now, this is enough for us. So you can paste and press enter. This is gonna use pip, which is the standard package manager that Python have, right? So after that, we can run ADK version. And this is gonna show for us the version that we have installed of the framework. So ADK version 2.0, which is new. So that's good. And now we're gonna run this command. So if you haven't used Google ADK before, this is the way that we can create agents using Google Framework. So we create Google ADK, create, and then my first agent. So we can copy this and paste this again. They are gonna ask us two questions. If you wanna use that model or the second model, we can go with the first one, and then we can use Vertex AI as our standard authentication thing. Nice. So let's just double check that this project is the one that we have selected on the top. So it is, right? the same thing. So just press enter. And for the region, we can keep as is, right? So after that, you can see agent created in this directory. So if we do an ls LAH, you're gonna see that we have this folder. Why we name it my first agent? Because we have named it like that. So this is the basic version of creating an agent on ADK. So this is the standard folder structure that we're gonna have inside of it, right? So if we enter the folder cd my first agent, we can do an ls LAH, and you're gonna see agent.py, env, and init.py, right? So right now, we can edit our .env, and we can just check if the information match. So we're using Vertex AI as our authentication method. We're using this project, and we're using at this location. So this is what we should expect. So it is good. We can just Control X and leave. And right, and let's go back to our tutorial. So that's we have some ways to run our project in Google ADK, and one of the ways that we can do it is running ADK run in the name of the folder. But first, I need to go back one directory. So after doing that, I can do ADK run my first agent, and we should expect a command line interface where we can infer some questions. For example, hi. And let's see what this is gonna answer for us. Hi there, how can I help you? So we can see that the model is working, the authentication is working, and the agentic system is working. Even though it is simple, it is working. So nice, it is our first step here. So let's ask something more complex to the agent. Review this Python code over here. So remember, we started our session saying that we're going to create an agentic code review pipeline. So let's test as one shot. Let's see if the agent has been able to answer us something regarding this. Yeah, it answered. Let's see. Let's see what it's saying. Okay, let's review this Python code. Printed the code again. Overall, this is a very simple, correct, and readable function. It does exactly what its name suggests. Detailed review. Looks good for you? Yeah, looks good, I think. It is a good review. But if we go back, was it actually able to parse the code in ESD, run tests, check the style compliance, and remember from our previous reviews? No, it is not. So even though we use it ADK, our pipeline is far away to be ready. So right now we're gonna start and we're gonna really create our project. So we can go do an ls LH, and we are gonna right now remove our page, our folder, I'm sorry. So if we do the same command again, we're gonna see that our folder has been removed, and now we're gonna really start our project, right? So just a mandatory thing, if you guys have any question, you can leave on the comments and I can answer it later, right? So no worries to do this at the same time as I am doing. You can do it later at home, but the only thing right now is just to pay attention and see how the engineering process is going, and then you can try it at home, right? So no worries if this became too fast. So the first thing we're gonna do, we're gonna clone this repository. So let's clear, let's paste, and you're gonna clone. Nice. So if we do the same command again, we're gonna see that has been cloned, ADK code review assistant. Then we are gonna enter that folder, and you can see that has entered over here. And then we're gonna change our branch to be the code lab branch. Right, so everything seems to be ready. So the first thing we're gonna do, remember that we haven't done that for the first example. Right now, as the code is more complex, and as we're gonna need more libraries, we're gonna need to create our virtual environment. So right now, we're gonna create inside of the folder, remember, the virtual environment. So Python -m venv, which standards for virtual environment, .venv, right? So this is gonna create a folder for us, and the name of the folder is going to be .venv because we name it like that. It can be dot everything that you want. And then we're going to activate our virtual environment. So you can see right here that the environment has been activated. So the same name that we have here is the same name that we have defined over here. And then we have reference right over here. And if you do an ls like that, you're gonna see that you have the folder right here, So everything should match. After that, we're gonna make this command. pip install -r code review assistant requirements.txt. So when we run this thing, it's gonna look at our file named requirements, and it's gonna look into every library that we have defined as requested, as necessary, as mandatory, and it's gonna download each one of them inside of our active virtual environment. So it's gonna download and it's gonna pack everything that we need inside of that environment so we can run the code in the same way everywhere that we want, right? So we're gonna keep the versions up to date and then easy to be installed in every other machine or Docker container or every other thing that we may use. So this sometimes can take a little bit of time because we have a lot of libraries being used on the back. So it is gonna download everything first and then install it, and then we're gonna be ready to keep going with our code lab. But essentially, this is the standard process that we create and do in pretty much every Python application. We create a requirements file with all the libraries that we may want, and then we are gonna install it. Let me see the comments while this is running. Thank you, GDG team, for sharing the link on the comments. Nice. So it has finished. So we have, at this stage, downloaded everything that we need for our workshop of today. And then we're gonna run that command that is gonna allow us to run our folder as a module in Python. So this is gonna make the things easy for us when we start to test in some steps after here, right? So as we go to our workshop, you're gonna notice that things are simple to be done. So you can pretty much read the instructions, copy and paste. So this is by purpose, so you can easily replicate the content. So looking here, we're gonna copy the .env.example into this new file called .env, and then we're gonna edit this file because we need to put our project right here. Remember, we have cloned this code, so we don't have the information yet. So we should go back, copy the project ID, and then paste the project ID over here, and then we're gonna just erase some spaces, and then we're gonna save it doing Control O and then Control X. So let me just double check. Yeah, this is the only thing that we should replace, right? The other things we can keep is as is. Nice. So for our safety, we're gonna run this thing again, so we can be very sure that we are authenticated in Google Cloud. We can press Y, then we can follow again the code, select the same account, and repeat the same process. Copy, and then pasting it here. Nice. So remember, the project is the same. Now, we're gonna activate all of those services, and you can pretty much see that is way more than before because we are going to run a lot of things. We can deploy our solution. So we need the cloud build, we need the artifact registry to store our image, and then we have the storage, the cloud trace, the run, the SQL admin. So we're going to need all of those services for running our workshop of today. So you can pretty much enter the comment again. If you see something going wrong here, you can follow the steps and then make sure that your account is ready to use those services. We can create this, but we are not going to push anything to production right now at this workshop, so I will bypass. But if you want, you can create this repository on Google Cloud Artifact repository. This stands for a place where you can push images, Docker images. So this is like creating a folder to store the images if you haven't worked with artifacts yet, right? So this is pretty much simple. This is just creating the repository on our Google Cloud platform. So if you go to console.google.com and then artifact registry, you're gonna see that you have created this repository. So we're gonna bypass right now, and then that's okay. So what are we gonna do now? We're gonna create two variables on our environment. The first one is gonna be named project number, and then the second one is gonna be named service account. And this is gonna be defined getting the value of our Google Cloud project that we have been working a lot of times in this session. And then we're gonna use this again to define our service account, right? So you can copy everything here and you can paste everything here. Let's wait a little bit. It's gonna be answering us on the terminal for each of the services that we have requested. So it's gonna update like 5 times, right? We can go to the step 4. And right now we are gonna really and finally start our code work right here. So just remembering, let me go back to my slide. We're gonna build 2 pipelines, right? The first one is gonna be a review pipeline, and the second one is gonna be a fix pipeline. So now we're gonna build this first one, and then we're gonna build the other one. So for the first pipeline, we're gonna go from the simple LLM agent, the one that we have done before. Remember, creating ADK, create my first agent. We're gonna go from this to an agentic with deterministic too, because guys, LLMs by itself is not deterministic, it's a non-deterministic thing. So how we can make things more deterministic? This is why Google have created ADK, to make LLMs more deterministic. And the way we're gonna do that is introducing states, introducing really good tool set, and really good context management. So we're gonna do all of this using ADK. So first, we're gonna create an agent that is gonna analyze our code using a specific tool that is gonna analyze the code itself using the tree structure, and then it's gonna store that result of the analysis into a state variable, right? So before we start, let me just clarify another thing. Let's suppose that you have create 2 agents, an agent that sees the code, and another. No, let's suppose you created just one agent using the same tool over here, code analyzer agent with this analyze code structure tool, right? And you create inside of your tool a parameter named code. So what do you expect the LLM to do? To pass the code that you have sent into the tool as a parameter. And I point a question here. Can we trust the LLM to do this kind of work? Can we really trust that LLM will not miss a semicolon, miss a parenthesis, miss some piece of code? We cannot trust. So we should have a better way to pass information through agents, through tools, through another agents, or through another functions inside of our code. So the way we do that inside of ADK is using session states. So that's why we are gonna get the result of this agent and store into a state. And states stands for variables inside of our code pipeline, right? Inside of our agentic pipeline. So states is where we store data and where we can access that data inside of the tools, inside of the agents, inside of everything regarding our pipeline. So this is a very great piece of advice that I leave here today for all of you. So let's go back and then let's open the editor right here. And you're gonna see the folder. We're gonna open this and then let's open the sub agents and let's open this review pipeline. So the first thing we're gonna do is on the file named tools.py. So let's open this file, tools.py, and you can see that this is like plug and play. We have this hashtag here with the step, and then we're gonna look at the code lab, see the step, replace, and do this as Lego building blocks, right? So we're gonna find for this, we're gonna search for this, and then we're gonna replace this over here. Remember that I have just talked about states. This is how we do it. We're gonna use this tool underline context dot state using this key. This could be like Pedro or whatever, right? This is just a dictionary. So we're gonna store into the states the code, the analysis, and then the code dot split lines. After that, we're gonna search for this, and then you're gonna replace this other piece of code right here. Nice. So this is creating a thread to executor loop. So that's how we're gonna run our piece of code that is gonna extract from our characters, from our string that represents our code, the structures presented on the code itself, right? So this is how we're gonna do it. And then let's go down a little bit and copy for the module 4, step 4, right here, this piece of code. And I will give a quick overview. Let me just paste this, and nice. So if you look here, we are working into this function, analyze coding code structure, right? And this is the function that is gonna receive our code as a string and is gonna take the tool context as a parameter to create a very good analysis using this helper over here, extract code structure helper with this underscore on the first part of it, and then it's gonna store the result on our context. So this is the tool that we have been working here, right? After that, we are gonna paste this helper function here, which is the brain of our tool. So we are gonna search for the helper function hashtag, and then we are gonna paste the full function over here. I will not enter in details right now because first we will not have time and we need to rush. So this is the helper function. You can see the details after, but this is what we need for now. And then we're gonna now look into our agent. So we're gonna go inside of the sub agents, review pipeline, and then code analyzer. And here on this step, we're gonna paste our agent. So remember, this is the same structure that we had on the first example, but right now with a little bit more of complexity, right? Because right now we have tools over here, and it is referencing our analyze code structure tool, right? Inside of tools, look here. And this is another creative thing. Remember that we have been storing inside of our tool into a state. Let me go down a little bit. What is on the top? Here, that we are storing this inside of the tools, inside of the state. Right now, when you look into our code analyzer, you can see this output key, what this stands for. This is saying for the agent that whatever it have returned, please don't tell this to the user or don't tell this to another agent. Store whatever the result may be inside of this key on the state. So this is referencing the state again, but inside of this key, right? So whatever the result of this agent might, maybe it is going to be stored inside of this key. Nice. Let's keep moving. Now we're going to run this script. Let me go back to the terminal. Let me do this just to double check. And let's run this piece of code right here. Python test/test code analyzer. This is gonna send for us. This is a standard thing. And let's wait a little bit, right? This should return for us this kind of response. So it should return an analysis of our code itself. So we should wait a little bit and then we can get this answer. I don't know if things in Google are a little bit slow today because of the launch and everything that is going on at I/O. But if this takes more time than we expect, we're gonna stop it and then we're gonna keep moving with our code lab, right? So while this is running, let me go back and let's move to our 5 dot right here on our 50 step, right? So we have created the first agent, the code analyzer, but we have still more 3 to create and then orchestrate this inside of a sequential pipeline. Nice. So let's go back to the tools. Let me go back to the console. This is taking a little bit of time, so I will do Control C. No problem. Let's go back. Let's go to the tools and let's search for this style checker tool. Then we are gonna replace with this function. Again, we are creating tools for our agents. So let's go down. Let's search for the helpers and let's paste the content of the helpers. Nice. Let's go back to the code lab and let's then go to our agent. So right now we have created 2 tools and then we're going to create the agent that is going to use that 2 tools. So let's go to the style checker. And this is going to show us some new things. The first thing, the first concept that we are introducing here is this called instruction provider. So right here, you can see that we have defined this function, style checker instruction provider. And this receives as a parameter this context of the type read-only context. And you can see that we have this tag structure analysis summary. And then at the end, we are returning a promise and awaiting our instruction use dot inject session state using our template, which is this variable here, and then passing the context. What this is doing, Pedro, right now, this is looking into our context. Again, the same context that we are storing here, the same context that we are placing on the AST function here, they are all the same. And when we create this, we are looking into our context. Let me go back. We are looking into our context, and if we have a key named like that, we're gonna get the content stored on that key, and we're gonna replace inside of this, right? So what this is doing is like states do have some value stored on this key. If you do so, please replace on this file. And then we're gonna use this as our prompt for the agent. So this is the really cool part of working with states, right? So you can use this in different sort of places. Inside of the tool, as we saw, as a response, as a way to store the response of some agent, and now as an instruction provider for our agent. So let me get this here, the second part, and let's replace our style checker agent right here. And you can see that instead of passing the strings itself, as we have done here, if you look here, in the same property, we have passed the strings. Right here, we passed the function, which is the instruction provider we have done. And then again, we are storing our result inside of this output key, which is inside of our states. So let's keep moving. We're gonna now open this test runner.py, this other agent, and then, if I'm not wrong, we're gonna copy the instruction provider over here. So again, this is the same thing we have done before. We are setting up instruction provider function. We are looking into the states and seeing if you have some code to review key, and if you have a value stored there, and if we have, we're gonna replace it, or it's gonna be null, it's gonna be empty, and then we're gonna create our agent that is gonna use the instruction provider. But here we have a new thing. You can see that we have this new property named code executor. So what this built-in code executor means, this means that Google ADK has the ability to run our code in a sandbox environment. So this means that the framework itself is able to test the code in a sandbox safe environment. So if you send that Python function that adds two integers and return the sum, you can see if the code is compiling and working or not. So your agent is able to test itself and then answer you the result of the test. So this is a very great thing that ADK answered and have to us right now. So after that, this is like a brief explanation, seeing and explaining the difference between state and memory. So memory is like, let's go back and see if Pedro have made that mistake before. And if you do so, we need to tell him, like, maybe you have a deficiency on that area. So Pedro, be aware that you have been making this mistake 5 times. And states is the way that we can store information across agents and across tools and across any different types of code and piece of codes inside of our agentic pipeline, right? So let's go down and let's keep moving. We're gonna go back and we're gonna open the tools file and we're gonna search for the search past feedback tools. And here I will introduce for you guys the memory concept. So if you come up here, let's go up here, search memory. So Google ADK has some ways for us to get memory on our agents. Let me just check if I can get the documentation right here, because we do have some types of memory. Let me search memory. Yeah, we do have them. Yes, this one. Not the, yeah, this one. We have the in-memory session service, so you can keep up the memory inside of the execution loop of the agent. You have the database memory session provider, so you can record the information inside of your DB, your third-party DB or your GCP ones. And then you have another one that is not being shown up here, maybe because I am on the wrong page, but you do have the Vertex AI Memory Bank service. So this is going to connect into the Vertex AI and extract from the logs of your conversations with ADK all the relevant memories regarding your conversation, and then it's going to store that as memories. So it's going to get your, for example, your WhatsApp chat and then the agent chat, and it's going to look into that conversation and extract memories. For example, if you have told an agent, I like to run my Python code that way. I like to install my packages using UV instead of pip, or using UV with pip. The ADK, the Vertex AI Memory Bank Service, is going to extract that and is going to record a memory saying that Pedro is more likely to use UV with pip than just pip itself. So this is a very good thing, right? And the way we search things inside of the memory is using, again, the states, but this is connected to the memory that we have chosen before, right? And then search memory passing a text string. Nice. So let's go down, keep going. Let's replace that function. And again, I will not have time to explain all of the functions, but you can pretty much infer when you create this at home. Let's keep replacing. Nice. Then we're gonna go to the agent that is gonna use those tools, and the name is feedback synthesizer. And then we're gonna replace both the instruction provider right up here, and then we're gonna replace our hashtag with our agent. So if you look, you have the model, set it up, description, the instruction with our instruction provider, and then the tools. And then the result of all of those things, we're gonna store into our output key, which is gonna store inside of our states. So right now we have 4 different agents, but they are not working together. So we need to build our orchestration. So right now we're gonna go back and we're gonna open this agent file right up here, and we're gonna place all of the necessary imports that we have, right? And then we're gonna replace this, and we're gonna create our pipeline. And I will briefly explain something for all of you. Yeah, look at this sequential agent. What this stands for? Let's suppose you have an agent named A, another agent named B, and another agent named C. And then you create another agent named orchestrator. And then you write on the prompt, please, orchestrator, run first the agent A, then the agent B, then the agent C. Can you trust and can you say me with 100% sure that the orchestrator is going to call the agents in that sequence? No, we cannot, because LLMs are not deterministic. So what we are doing here, we are using a sequential agent structure built from ADK team that is gonna run those sub-agents sequentially in the way that we have defined them. So this is gonna run the agents using really code, like code loop structures. So this is gonna firstly code the code analyzer, then the style checker, then the test runner, and the feedback synthesizer, and this is gonna be called at that way without me being wrong. So there is no way this goes wrong, because this is a futuristic tool that ADK has brought to us right now on the framework. So with the sequential agent pipeline, we can assure with 100% sure that we're gonna call the agents in the sequence that we have defined. So this is very good, right? So if I go back here on the documentation, let's see if I can quickly show sequential agent. Let me see here. workflows. I want to show all the types that we do have. Template workflows. Let's see. Yeah. So we do have this. We have sequence agent, the sequential agent that is gonna execute the A, the B, the C, that is gonna execute in our case, the code analyzer, style checker, test runner, feedback synthesizer. Then we have this loop agent, which is the second structure that we're gonna use when we start building the second fixed pipeline. And then we do have the parallel agent that is gonna execute those agents in parallel, right? So good. Let's go back to our code lab and see if we can test. So let's go back. Let's go back to the terminal. Let's go one directory on the back, and then let's run ADK Web Code Review Assistant. And let's see what this is gonna return for us. So let's go back and let's run another command. Call it, let me get here, the Python dot e. One sec. If this happens for you, maybe this is the solution. This is replacing. This is creating the things. This one is copying the env, and this one is instantiating our thing. Let's just check if we need to run this inside of the page. Maybe yeah. Maybe I'm spelling it wrong. CD. Oh, this is it is the name, right? So it is. We should go inside of this folder, ADK dash code dash review dash assistant, and then we should run. Sorry, not that command, but we should run the other one, ADK web, this one, right? So this is gonna allow us to run our project. Nice. So it is nice up and running. Let me just go back to the step that we had. And this I want to introduce a new tool. For example, as I said before, we are running inside of a Google machine. So how can we access this local host result? How we can open like an ngrok session and then access on our browser what is running locally inside of the Google data center. Right up here, web preview, right? So look and pay attention. Preview on port 8080. This is wrong because we're running on the 8000. So we should click and change port and then 8000. And now we're gonna see what is happening inside of this address right here. You can see that we have all of those requests. So this is a good sign that we have opened at our repository over here, right? So this is showing up sub underline agents. This is wrong because when we run like that, let me show you. Let me show you right up. Where is it? Let me go back here. ADK Web Code Review Assistant. This is entering that folder, and then it's gonna showing up all of the folders that we have inside of the folder that we have named. So the only folder we have is sub-agent. So if we remove all of this and then just run ADK Web on the root, it should show us, let's wait, and then let's close web preview and preview on port 8000. And you can see that now we have the code review assistant folder, right? So with that, we are able to test our code, and let's see if the agent is able to answer us something. And hopefully it will be able. Sometimes you can face the 429 error code, and this is a common thing at this kind of workshop. So if you face that, you can just ignore and try it again later, because this is a standard behavior that we sometimes face, right? So looking up here, we're gonna see, this is, if anyone here is new into Google ADK platform, this is a web interface where we can interact with the agent that we have been doing, the pipeline, everything. And you can see all of the agents that is being requested. So the moment I send a message right up here, I am passing through this agent file, right, to this root agent that is gonna call the code review pipeline, and then it's gonna pass through every one of the 4 agents that we have defined. So if you look up here, code review assistant, then code analyzer, remember the same name, then code review assistant, then code analyzer again, then style checker, and then come up. Let's go back, let's go down. It is still processing root agent, and then maybe it's gonna pass to our feedback synthesizer, and then it's gonna show us some result. Yeah, feedback synthesizer, call it search past feedback to see if I have made that mistake sometimes in the past. So then this is still running, but you can pretty much see that we have executed all of the agents that we have created. And if you click, you can see the full trace regarding the execution, regarding the agent. So you can see all the parameters, all the requests, all the response, all the graphs and everything. And look, we have a very cool result over here of a very great analysis of our code. And this, the pipeline was able to make a style checker using AST, searching for past feedback memory, running the coding sandbox and getting the result, and then synthesizing everything into a single great feedback. So this is a very great summary, way better than our one-shot test that we have made on the beginning of our workshop. So I want to ask right now the GDG team if I do have some minutes or if my time is finished, please. Let me check.
Hello, yeah. No, you can continue. There's no problem. Yes.
Okay, thank you so much. So we are gonna do the second part of the pipeline, which is the code fix one, and then we finish our workshop of today, right? Yeah, I can share my social media. Let me send up here. This stands for Instagram and LinkedIn. So if you guys are gonna post something, please tag me so we can keep tracking. We can keep track of the engagement, right? This is important for the program. So yeah, this is good. We made the pipeline. The pipeline worked. Everything is working fine. So Pedro, how we can improve it? That's the answer. We're gonna create a fixed pipeline. So moving back to the slide, we have pretty much made the first one, the review pipeline. And then we're gonna create this fixed pipeline using our loop architecture. So instead of executing agents sequentially, we're gonna execute the agents in a loop until the condition is achieved. For example, if you work in programming, you can use the while code structure to replicate what we are doing here. So essentially, it is the reverse thing that the ADK team has done. It is replicating the while structure using our fixed pipeline or our sequential or loop pipeline structure, right? So this is what we're gonna do right now. We're gonna still create for agents, but we're gonna loop them inside of this loop structure. So let's go back. This is a brief explanation of what a pipe of what a sequential pipeline do and what a loop pipeline do. So you can read this at home, but I have already cleared it right now. So let's go back to the code, open the editor, and then instead of going to the review pipeline folder, we're gonna open the fixed pipeline folder, right? So after that, we're gonna search for this into the code fixer.py, and then we're gonna paste our instruction provider, which is the same thing that we have done before, and then paste the agent itself. And then remembering instruction provider, inject session state, get information from the state, getting everything, and using our code execution to run the code inside of ADK standard structure, right? After that, let's go down. We're gonna open this file over here, the fixed test runner, which is the other agent that we're gonna be doing today inside of this code fixer pipeline. We're gonna paste the instruction provider here. And again, we have more tags to replace, and the ADK is gonna do that for us automatically when we call instruction utils inject session state. This is a standard function from the library. So we import from google.adk.utils and then we import instruction utils. So it is all packed inside of the Google ADK lib. And then we're gonna paste again the test runner agent. Oh, sorry. Let me go back. We're gonna paste the test runner agent. And then we're gonna go into the tools file, the same file that we have been doing for the other pipeline. We're gonna paste this validated fixed style function that we're gonna use. Then we're gonna paste this that is gonna compile all of the information that we have for our report. And if you look up here, it is gonna compile the status, the emoji of the status itself, the timestamp, the original code, the fixes that have been done, the improvements, the test, the style, and the summary, right? And then again, let's remember, storing everything inside of the states. Right, so let's go down. And then this is a very important thing. Exit fix loop. Let me go back to the slide. Look here. We are gonna run the fixer, the test fix, and the validator in loop. So how we can stop the loop? How we can make an early return? How we can make a break right up on the loop structure inside of ADK? And the way we make that is using this function here, escalate. So every time we escalate, we're gonna stop our loop, right? So if you check this tool that we have defined, we're gonna, inside of the tool context, dot actions escalate equals true, right? So every time we run that, our loop, whenever and whatever stage it is gonna be ended. So that's important that we just call that function inside of our final agent of the loop, and if the condition is matched. So if the condition is matched, we call that function. Otherwise, we're gonna be in loop for a long amount of time, right? So there is two ways of breaking the loop. The first one is using escalate, and the other one is suppose if your true conditions is not matched. If you try it 20 times to fix that code and you can't for some reason, if the agent can't for some reason, how does this end the infinite loop? Using the max property. So if you come up here, we're gonna have a max of 3 iterations, because as you may imagine, each iteration is gonna cost some tokens, is gonna cost some other money in the other third-party services that we may be using if we make this more complex than what we have been doing today. So loop is money, and then it's good for us to make and to define our max iterations value to be low, like 3, 5, or like 6, 7, and not more than that, right? So the standard is 3, and that is what we are gonna be doing today, right? So then let's go back to the files and let's go to the fixed validator agent. Then we're gonna paste the instruction provider on the fixed validation agent, right? So look up here, we are requesting the same emojis that we have defined on that function, and then we're gonna define the agent itself. Let's go back. Let's define the agent. Then calling the tools, storing the result on the output key, which is standards for our state. And then this is gonna just explain for everyone what I have already explained about the escalate and about the max iteration exit. So there is two ways of getting out of a loop. The first one is using escalate on the queued example, and then if the true condition is not being reached, it's gonna escalate through the max iterations. So let's go down, and then we need now to create our fixed pipeline inside of the main file. So remember, when I have made the demo, when you type a message right up here, it calls this file, agent.py, right? So right now, we just have the sequential pipeline, which is this one. And now we should get together all of those things inside of the final fixed pipeline. So let's go back, and then we are gonna go right up here and paste. Let me paste on the bottom right here. Nice. So what we have done, we have imported all the 4 agents that we have created. This one not yet, but we will soon. And then we have imported this new one called loop agent. So instead of using the sequential pipeline for this one, the sequential agent for this one, we're gonna use the loop agent. So that's why we have imported. And then we're gonna create the fixed loop, replacing the tags. Let me go here. Creating the fixed loop. And then we need to update our root agent, right? Because this root agent over here just refers to the code review pipeline. But we need now to refer the fixed pipeline as well. So then we should remove, delete, and now we have the sequential pipeline, the fixed attempt to loop agent, and then another sequential agent that receives the fixed attempt to loop, which is a loop agent, and then the fixed synthesizer, right? So in real world, we have one sequential agent which has as sub-agent the loop agent itself, and inside of the loop agent we have the 3 other ones, right? And the 4th agent that we have not created yet, which is the feedback synthesizer, the fixed synthesizer rip agent, we're gonna put this inside of the second sequential pipeline, right? So then we're gonna go back, and then we're gonna define our root agent, our final root agent. And if you see, it is gonna refer to the code review pipeline and then the code fix pipeline that we have done. Nice. And now there is one more agent that we should create, which is the fix synthesizer. So we should open that file, fix synthesizer one, then we should paste the instruction provider over here, And then we should place the final agent over here. Nice. And then you may notice that we have this tool that we haven't defined it yet. So we should define it right now. So we go to the tools.py again. And then there is just one tool missing, which is this one. So we copy and paste. Nice. So all of our tool file have been replaced, our of agents have been created, and right now what we should do is really test if everything will work and will work fine. So let's go back. Let's go back to our page and let's run again ADK web. And let's wait a little bit. Nice. So compile it, everything worked. So let's test. We're gonna open the web preview. You'll notice that the port is still 8000 because we have changed it before. So it keep as the last value that we have changed. So preview on port 80,000. And let's see. Select the agent, code review agent, and then we can paste this, which is the same example that we have pasted before. And now, this is going to take a little bit of time, but it's going to run through these two pipelines that we have built. And with that, we finish our workshop of today. Let's just wait until this gets some response for us. But the other steps that we may or may not follow right up here is going to be deployed to production. So this is going to deploy into our artifact registry, and I will show that for you as soon as we finish the demo. And it's going to talk a little bit about the production observability that we have inside of the Google Cloud Platform. So we can infer all of the traces, the agents, and everything that we have here inside of our detail. So let's wait until this answer us something. If this is not, let's see. Don't know why it's taking so long. Let me pause. Let's wait a little bit and then we can run it again. Sometimes this thing happens. This is also a rushed day for Google, and we also have some 429 error that may happen. So let's wait a little bit until this finishes. But in general way of saying, this is gonna answer for us the same kind of result that we have expected on the first example. But in addition, we're gonna have all of the second pipeline being executed and in loop being executed right now. So yeah, for some reason it is taking a lot of time. I will not be glued to this right now. So this is what you guys should expect. This is gonna run those two pipelines and then answer us back the same kind of response that we have had on the first example before we create the second pipeline. Yeah, we have a question from Ryan. What is the difference from state and memory? Essentially, memory is something that you can use as a long-term variable or context for the agent. For example, every time you run this pipeline, you are repeating the same mistake, and then you store that kind of information, that you have that kind of deficiency on that skill, or that you have some preferences, or you have some specific thing related to you, and then you store that in a database, and then use this as a context to improve your final answer, right? The model final answer. So whenever the agent is analyzing your code again, you should be able to get from the memory your past reviews and use that as a context for the review that time. This is memory. State is different. State is the way you pass information through the agents and through the tools inside of the execution. So if you have a property, if you have a result, an output, everything that you need to access, information that you need to replace on your prompt, for example, the personal preferences itself, or any other thing, you're gonna use states to get that information from a place that is immutable, that is trustable, and pass to the agent. So you are not passing the obligation of storing the state for the LLM. You are doing this by code using the memory itself. And then you are retrieving whenever you need the information for the LLM.
Thank you so much, Pedro. We also have another question from Brian. He asks, and how can apply long-term memory reduce tokens, always doing indexing the information about messages?
Yeah, sometimes you can index the information if it is too long, but a way that have been working fine for Google and also in another project, if you don't want to use the Vertex AI Memory Bank service, let me pull up this on the screen. Vertex AI Memory Bank. Let's see if this is gonna open right up on what we want. Yeah, nice. So for example, if you have a very, very long conversation, a lot of times, you should not store everything and pass everything to the agent, right? You should reduce the number of tokens, of the words, of strings, of whatever information you may need. So this is a great way. It looks into the full file, so you can create a pipeline to make that is going to look into the full extracted conversation, and you can extract what is more relevant for your context, for example. What is more relevant in this conversation in user preferences topic. So we're going to analyze if you mention something that is relevant, and then you're going to get only that piece of information and store it. You can get this piece of information and embed, make this tokenizable. I don't know if this word exists, but you can pass this through an embedding model, get the vectors, and store that on the vector database. So if you have a large amount of memories, you can search by that using embeddings. So it's gonna make your answer better. And if you want, you can even use a re-ranking model and short your top K to be smaller than the default one, right? So this is an advanced technique to make a re-ranking on the reg using the vector DB from the extracted memories. So in that way, you can get better answers from this full context that the agent has produced.
Thank you very much, Pedro. That was an absolutely fantastic workshop. I love how you broke down the process of building a multi-agent system and showed us how to mix deterministic tools with LLMs to analyze the code structure. I loved seeing the automatic iterative fixed pipeline in action where the agent corrects issues, validates them, and retries until the code is perfect. That was amazing. That was definitely a game changer for all of us. And topping it off, with production deployment on Google Cloud, that was like the perfect closure. So we really appreciate you taking the time to share your incredible expertise with our community today. Pedro, it was an absolutely honor having you. Y ahora, para toda nuestra comunidad que nos acompaña hoy, muchísimas gracias por conectarse y por seguir el Code Lab paso a paso junto a Pedro y por mantener el chat con un bastante buen nivel de preguntas. Hoy, pues, nos llevamos un gran aprendizaje. Ya no somos solo usuarios de IA, sino que también hoy aprendimos lo que son las bases para poder construir nuestros propios agentes de nivel de producción usando el Google ADK. Recuerden que la mejor forma de poder dominar esto es pues meter las manos al código, ensuciarse las manos y seguir experimentando con lo que Pedro nos enseñó hoy. No olviden seguirnos en nuestras redes sociales de la comunidad para no perderse los próximos talleres y eventos de Build with AI. Muchísimas gracias y que tengan una excelente noche. Nos vemos a la próxima. Pedro, thank you very much. We hope to see you.
Thank you for having me. I am so happy and grateful to this invitation. Yeah.
Thank you very much. Bye-bye.
Thank you. Bye.
Bye. Thank you.
Bye.